Welcome to EDU World Space.
Here, the rate of water flow Q is 40 feet cube per minute. The water flows at A with velocity VA is 75 feet per second at the angle 60 degree you can see over here, and at the point B the velocity is again 75 feet per second and the direction is horizontal. So these data are already given. Now to calculate the mass flow rate we can use the formula, that is dm upon dt is equal to gamma q upon g. Now let's substitute all the values. So it is nothing but 60 2.4 upon 32.2 into 40 upon 60 is equal to nothing but 1.292 pound into second per feet. Okay, let's move towards the next step. So in the next step, we will apply the impulse momentum principle as shown in the figure. So according to that, sigma md 15 inch upon 12 inch per feet delta mva sine 60 degree plus 23 inch upon 12 inch per feet delta mva cos 60 minus 15 inch upon 12 inch per feet C delta T is equal to 3 inch upon 12 inch per feet into delta MVB. Okay, now by simplifying this equation, we will finally get the C is equal to minus 29.006 pound. Okay, let's move further and let's talk about the x component and then we will talk about the y component. Okay, so let's calculating for the x component. Here I'm going to mention as a x. Okay, so what I can write, that is a dx delta t plus delta mva cos 60 is equal to delta mvb. Again, we will put all the values and calculate the dx. So the dx is equal to 1.292 into 75 minus 75 cos 60. Okay, so the final answer will be 48.4 pound. Similarly, we can calculate for the y component, which is nothing but in the vertical direction. So y component in a vertical direction, what I can write for y is a dy delta t plus delta mva sin 60 plus c delta t is equal to 0. Okay, so here my dy will be equivalent to minus 29.006 minus 1.292 into 75 into sin 60. Okay, so my final answer will be minus 54.9 pound, which is in the y direction, or I can say dy. So kindly consider the final answer as dy dx, and our c value